Hello class. So last lecture was totally based on the classification. Now let's try to write the name of the organic compounds. That is called IUPAC nomenclature. That is one of the most important topic and basic of organic chemistry. Because without knowing the name, we are not able to learn anything in the organic chemistry. And there is a proper method, proper rules and regulations to write the name. And for that, the one a chapter was there in class 10th also. There also given some basic rules and regulations for IUPAC naming. But here, that is in a broad way. We have to learn how to write the name, and for that we have to learn some important rules. So in today lecture we first try to learn some rules, regulations of naming. Then after, in the next lectures, we'll try to learn how to write the name. Okay, first let's try. For nomenclature we have to know the something like a functional group, then parent chain, suffix, prefix, word root, some important terms we have to learn first. Okay, what is called functional group? All those group which having a atom other than carbon and will decide the functions of the organic compound. All those group which decide the functions of the organic compound is called functional group. Like carboxylic, like ester, like aldehyde, like ketone, like alcohol, like amines, like ether, like nitro group, like halogen group. These are called functional group. Carboxylic, ester, aldehyde, ketone, alcohol, amines, ether, nitro group, halo group. Halo group means halogens, chloro, bromo, iodo, all the things. Other than that, there are also double bond, single bond, double bond, and triple bond. For that, we are using some kind of name like alkane, alkynes. So these are called functional group, which will decide the functions of the organic compounds. No matter organic compounds contain how many number of carbon, but if the functional group is present, the functional group will decide everything about the organic compound. Everything. Like a numbering, like a naming, the process of naming, all the thing will be decided by the functional group only. So these functional group will actually distinguished by their symbols COH, carbons. So look at the symbols first. Actually, in COH, the carbon contain double bond O, single bond OH. And in ester, there is carbon double bond O, single bond O, and with having carbon chain. R stand here carbon chain. CHO again carbon double bond O with hydrogen. And ketone contain carbon double bond O, both side carbon chain. OH, NH2. So that is same as given OH, NH2. So you have to learn the carboxylic acid, how to write here, ester, how to write, CHO and CO. What are the basic differences between among these structures, functional structures? Look at carbon double bond O, then OH, carboxylic, carbon double bond O, and hydrogen substitute by carbon chain, that is called ester. Carbon double bond O, hydrogen, not oxygen, that is called aldehyde. Carbon double bond O, but not hydrogen, called ketone. That is the only difference. That is the only key difference which will decide how to learn, how to distinguish among these functional group. Because without distinction, without identification, you are not able to learn their property, their naming, their procedure of naming. So you have to learn that only. Okay, what is called parent chain? Parent chain means in any compound, in any organic compound, the carbon chain that contains maximum number of functional group and maximum number of substituent is called parent chain. The carbon chain in organic compound that contain maximum number of functional group and maximum number of substituent is called parent chain. For example, look here. Suppose we have carbon, 4 different carbons are there, and there is OH, one of the functional group OH. Look here. So this carbon chain, that is a 1, 2, 3, 4. In this chain, 4 carbon is there, and this carbon chain also contain 1 substituent carbon, 1 functional group. So that chain is called parent chain, and numbering will be run through this parent chain only. Numbering will run through this parent chain only. This is called carboxylic, ester, aldehyde, ketone, alcohol, amine, ether, nitro, halogen. So whenever these groups are attached with some of the chain and the chain is longest for numbering, so that chain is called parent chain, and that parent chain we are using some word abbreviation for that parent chain is called word root. If the one number of carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for that we have some abbreviation of word that is called word root, that is meth, eth, prop, but, pent, hex, hept, oct, non, and for 10 that is called dec. So word root is the kind of word abbreviation used for parent chain. If there is 4 carbon in a parent chain, that will be called but. If 5 carbon will be there, that will be called pent. So for parent chain or any carbon chain, we have one kind of word root, the word abbreviation that will indicate the number of carbon in the chain actually. If the chain will contain 10 carbon, that will be called dec. Okay? Okay. For bond, different kinds of bond along with the carbon. If there is a single bond, that is always called alkane. For this type of chain, for this kind of carbon bond for functional group, we are generally using one word abbreviation again that will end the name. That is called suffix. So suffix stand here, the word abbreviation used for different bond, different functional group for identification. For identification, how to know there is a carboxylic group is attached, how to know there is a aldehyde group is attached. So for that we have some kind of word note or word abbreviation that will end the name. For single bond, if all the carbon will contain single bond, then that is called ane. For double bond, if everywhere are single but any one place that will having a double bond, then we are using ene. And for triple bond, we are using ine. So that ane, ene, ine will indicate the presence of bonds, single, double or triple bonds. The same way, for different carboxylic acid, for ester, we are having a different word abbreviation that will indicate the presence of functional group. For carboxylic acid, we are having a word abbreviation called oic acid. That is called suffix. For ester, we are having a OH. For aldehyde, we are having a ALL. For ketone, on. For alcohol, we have having all. amines, we are having amine, ether, nitro and halo. Look at these three. Sometime when functional group is not enough large or enough priorities to having suffix, then only we are having a word that will end, that will start the name, that will start the name, start, that is called prefix, and the name, that is called suffix. When a word abbreviation add at the end of the name, suffix, beginning of the name, that is called prefix. For ether group, for nitro group, for halogen group, we are having some kind of prefix. This is called prefix. That is oxy, that is called nitro, and that is called halo. So we are having these different types of suffix and prefix. How to use these suffix and prefix will decide in the naming. We'll learn in the naming only. Don't worry about that. One important thing is called, so this is 1, 2, 3, 4. This is called numbering. This is called numbering. Numbering always will start from the nearest priorities functional group. How to decide where will be numbering will start? So that will start from the side of the functional group. The functional group, the important functional group should be in the nearest position. That side only will start the numbering. Like I am starting here 1, 2, 3, 4. If carbon chain does not contain, if carbon chain does not contain any functional group, then numbering will be depend upon the presence of one of the branch attached with the parent chain. How to decide the parent chain? Parent chain should be longest, should we have a maximum functional group, should we have maximum substituent. So when a chain, the carbon chain contain maximum functional group, maximum substituent, or maximum number of carbon will decide will be a parent chain. Fine. So 1, 2, 3, 4, 5. So this will be a parent chain because of having a maximum number of carbon. And that parent chain having one left carbon is called branch carbon or substituent, and will decide the numbering from the side of the nearest branch. From this side the branch will be at 4th position, and from this side the branch will be at the 2nd position. So numbering will start from the side of the nearest branch. So these 5 carbon will called parent carbon, and the chain is called parent chain. This is called branch carbon, and for them we are using some kind of word root. 5 carbon having a pent. 5 carbon, the word root used is called pent, and one left branch carbon that having one carbon only. So we are using meth. We are using meth. Okay, fine. One other suffix is there called branch suffix. Called branch suffix, that is actually YL. YL is a branch suffix. This is called primary suffix used only for bond. This is called functional group suffix used for different functional group. This is called functional group prefix. When there is not a suffix used for functional group, we are having some prefix for different functional group. So this is functional group suffix. This is functional group prefix. This is called bond suffix. This is called branch suffix. Branch suffix. So look at the naming. In this compound, in this molecule, we are having one functional group called alcohol, and for that we are using here a one suffix called -ol. Parent chain having 4 carbon, for them using a one word called but. There is single bond, so bond suffix will be -ane, and one branch, that is called 1 carbon only, so meth, and branch suffix is called -yl, methyl. So the name will be methyl, ol, but, and for single bond we are having -ane. Now to learn the procedure of arrangement of all these things. How to arrange the different suffix, different branch suffix, different branch name, parent name, word root. For them, we are having one simple rule. One simple rule. All substituent names, branch name, all prefixes should be before word root. Should be before word root. And after word root there will be primary suffix always. There will be always primary suffix. Then will be a functional group suffix also known as secondary suffix. Clear? Always will be functional group suffix that is called secondary suffix. The whole name will be like a systematic way. First we will write all name of the substituent, branch name, prefixes in alphabetical order, then word root name, then primary suffix, then at the end secondary suffix called functional group suffix. Let's try. Here the branch is called methyl. Methyl. The position of methyl is third. So we will write 3-methyl. We'll write 3-methyl, the word root, because there is no other prefixes or substituents are present. So we'll decide only methyl to write first 3-methyl with position. Then word root for parent chain, that is called but. The primary suffix is called bond suffix, that is in. And then after the secondary suffix called functional group suffix, that is called all. So the name will be 3-methyl-butanol. That is the name of this given compound depending upon how we write here. Now if you want to write the name of this compound, the word roots contain 5 carbon, and for 5 carbon we are having a pent. For 5 carbon we are having a pent. Then after one branch is there called meth, 1 carbon branch, meth. Branch suffix is called yl, methyl. Position of methyl is second. So we'll write 2-methyl. We'll write 2-methyl, 5 carbon called pent, and bond suffix is called in. Look at the difference. When functional group suffix, that is called secondary suffix, present along with primary suffix, the spelling drop from the spellings of the bond suffix. The primary suffix will drop e from the end, and we'll learn to write an only, an, en, yn, when secondary suffix is there. If secondary suffix is not there, we'll end with the e, in. So the name is 2-methyl pentane. 2-methyl pentane. So that is a very important thing. So all these things will contain all the type of the different rules. We'll first learn how to understand the presence of functional group by taking their symbols, maybe write as like this or maybe in the condensed form. What are their suffixes, like for carboxylic acid, oic acid, ester, OAte, aldehyde, al, ketone, on, alcohol, all, amine, all these things. Then try to learn the parent chain, how to decide the parent chain. The maximum number of carbons should be there in the parent chain, maximum functional group should be there, maximum number of branch or substituent, that is called parent chain, the identification of that. Then after the left over carbon, the left out carbon are called branch carbon, and there will be a one suffix used with the branch carbon called yl. So that will be methyl, ethyl, propyl, and commonly known as alkyl, alkyl, alkyl. Like alkane, alkene, alkyne, we are having alkyl for a branch carbon. Okay, suffix always should be end with the word. So we are writing these names. So first in this lecture, first try to learn how to use these type of things. Then we'll learn some other basics of the naming in the next lecture. In today's lecture, only try to learn the different functional group, their suffixes, some functional group with their prefixes, parent chain, and the small compounds for the practice. How to write word root, how to use word root, how to numbering. Numbering should be start from the nearest functional group. The functional group should be nearest in the numbering. If a functional group is not present, we'll decide by the numbering presence of branch or substituent. Okay, so next lecture we'll decide the other different things, how to use different functional group together. Okay, good day.